Hello everyone, and welcome to a special edition of Mythbusters. Today we'll be testing once and for all whether artificial syrup and pure syrup are actually the same thing. Up first to walk us through the math is our syrup-loving customer, Drew.
In our equation to find viscosity, we set up a force balance equation utilizing Stokes' law for drag and calculating the force of gravity acting upon the ball when within the liquid. The equation for the gravitational force on the ball in a non-negligible density surrounding it was the density of the ball minus the density of the fluid times gravity times volume of the ball. With this, we were able to set up our force balance equation and rearrange it to solve for viscosity. The equation ended up being 2 times the ball density minus liquid density times gravity times radius squared over 9 times the velocity. Ball and liquid density was obtained by simply using a scale to obtain mass and dividing it by the volume.
This means that the only unknown variable needed to calculate the viscosity of the fluid is the velocity of the ball as it falls. To do this, we timed how long it took each quarter-inch steel ball bearing to fall the length of the tube so that we could find the average velocity of the ball and substitute it into our equation. We decided to test pure syrup against Log Cabin, Mrs. Buttersworth, and Publix brand with water and molasses as references.
Our data is shown along with the calculated average viscosity for each fluid over 4 trials. In the order of least to greatest viscosity, we have our control group water, followed by 100% pure maple syrup, then a tie between Publix original maple syrup and Miss Buttersworth. Next we have Log Cabin brand maple syrup, and finally Grandma's molasses as the most viscous. We included molasses as a way of measuring the precision of the viscometer between trials due to its high viscosity and long fall time. From the different viscosities of molasses, we can see a lot of variance exists between each trial, an indication of a lack of precision in the viscometer. We also found a significant discrepancy between the experimental and expected values of the viscosities. This is largely due to how the wall of the container slows the sphere's descent by increasing the friction due to shear stress of the fluid. Even with these margins of error, we can still compare relative viscosities between each fluid.
And with that, this myth is officially busted.